Hi everyone, let's continue to talk about the Runge-Kutta method for systems of first-order ODE. The idea in generalizing the Runge-Kutta method for use on systems of differential equations is the same as for the Euler's method. That is, we updated each unknown functions u1, u2 using the basic Runge-Kutta formula and the appropriate right-hand side functions f1, f2 from the differential equations for the unknown. We now consider the midpoint method and the classic fourth-order Runge-Kutta method for systems. So last chapter, we only talked about the fourth-order one. Do you remember? We have K1, K2, K3, K4. And then the yi plus 1 is a linear combination of those K1, K2, K3, K4, and the yi. Okay? So the midpoint method, we only have two values. You can think about K1 and K2, but we actually call them K and M. Okay, so first let's look at the midpoint method. Is also called basic second order Runge-Kutta methods. So it's RK2. Okay, so for a single differential equation y prime equals f of xy, y of x0 equals y0, the basic second order Runge-Kutta formula is we have the k equals h times f of xi yi, and then m is h times f of xi plus 0.5h, and then yi plus 0.5k. And then yi plus 1 is yi plus m. So far, so good, everybody? And to apply this method to the systems of ODE. Okay, so now we have vectors. Okay, the u1, u2, un, they're the coordinates of the vector u. Okay, well, it looks a lot, but we can actually use the vector notation. Or the vector notation, then these guys tell us that u prime equals f, the vector f of x u, right? Okay, and then this guy tells us k, the vector k is h times f of x comma u. Okay, and these tells us that m, the vector m, equals h times f of x plus 0.5h, comma, here we have u plus 0.5k. So far, so good? Okay, and finally, ui plus 1. Remember, this I plus 1 is the index of the iteration. Equals ui plus m. So far, so good? So it's the same formula, we just put arrows on top of the u and k and m. Okay, so keep those in mind. Let's look at our example. Oh, by the way, let me write down the formula here, then we don't need to go back and forth to the previous page to look it up. Okay, so k equals h f of x u, m is h f of x plus 0.5h, and then u plus 0.5k. And then ui plus 1 equals ui plus m. Okay, so now we have 4 coordinates. Okay, and with n equals to 2. So we have initial conditions. So let's see here. We are on the interval 1 to 2, and we divide it into 2 subintervals. So this guy is 1.5. This is x0, x1, and x2. Then that corresponds to u of 1, the u of 0, and u of 1, and u of 2. Okay, u of 0 is... Sorry, abuse of notation. This one is actually the x value. So this is the x value. X equals to 1. But here, this this guy means the index. Okay, sorry about the abuse of notation. Yeah. Okay, so this is the initial value. Initial value we have 10, 0, 0, 1. So far, so good, everybody? Okay, yeah, I know the abuse of notation. I'm really sorry about that, but I couldn't think of a better way to do that. Yeah, because the subscript is for the coordinates, right? And then the superscript looks like powers or derivatives. So I don't want to do that. Okay. Okay, let's continue. Alright, so we have two steps. First step, I equals 0. X0 equals 1. Alright, then let's see. K, let's figure out what's the K. Well, K1 is H. By the way, what is H? What's the step size is 0.5, right? So that is H times F1. F1 is U2. So U2 of 0. Okay. And what is that? H is 0.5 times U2 of 0, which is 0. See? It's the second coordinate of our vector U. So this answer is 0. So far, so good, everybody? Okay, and then K2 is H times, see? This is minus 2. This is U2 of 0 over X0. H is 0.5 and then minus 2. Oh, U2 of 0 is also 0. And then X of 0 is 1. So this is also 0. Nice. K3. K3 is H times F as F is U4 of 0. H is 0.5. U4 is 1. So the answer is 0.5. Okay. And K4 equals H times, okay, this is minus 2 U4 of 0 over X0. H is 0.5, then we have minus 2 times 1 over 1. Oh, it's minus 2 times 0.5 is 1. So far, so good, everybody? So this is the K values. Alright, and then let's figure out the M. Okay, so M1 equals H times F of X0 plus 0.5H, comma, U plus 0.5K, right? And now let's see. Okay, this is F1. Alright, what is that? Well, H is 0.5. And then F1 is U2. So U2 is, well, the second coordinate of this vector. The second coordinate of this vector is actually U2 of 0 plus 0.5 times K2. Is that okay, everybody? Alright, so that equals U2 is 0. K2 is also 0. Oh, so the answer is 0. Okay. And then M2 is H times F2. So H is 0.5. F2 is minus 2. Okay, replace U2 by U2 of 0 plus 0.5 K2 over X0. Okay, but because U2 is 0, K2 is 0. So this guy is also 0. Is that okay, everybody? Alright, let's continue. M3. See, next one, F is U4. So M. Okay, I don't know whether I have enough space. Let's do M3 here, if you don't mind. This is 0.5 times U4. U4 is the fourth coordinate of, let me highlight it. This, okay, let me do it again. Let me highlight it. Okay, the fourth coordinate of this vector, which is U4 of 0 plus 0.5 times K4. U4 of 0, which is 1, plus 0.5, K4 is minus 1. So this is 1 minus 0.5 is 0.5. 0.5 times 0.5 is 0.25. So M3 is 0.25. Well, M4. M4 is H 0.5 times negative 2. U4 now becomes U4 of 0 plus 0.5 of K4 over X0. Okay, and well, U4 of 0 plus 0.5 K4. This is actually 0.5, right? So we already calculated. So 2 times 0.5, X0 is 1. 2 times 0.5 is 1. 1 over 1 is 1. So we have minus 0.5. This is, let's see. Sorry, I realized I have a mistake. So the bottom instead of X0, it should be X0 plus 0.5H. So X0 is, in that case, because it was 0, so it doesn't matter. But here, it will matter, because this number, X0 is 0.5, X0 is 1, and then 0.5H. H is 0.5, so we get 1 plus 0.25 is 1.25. Alright, so then we have minus 2 times 0.5 is 1. This is like 0.5 divided by 1.25. And let's figure out what this is. So 0.5 divided by 1.25. So the answer is 0.4. So minus 0.4. Yes. So we have to be careful because the exchange sometimes is also convenient to calculate here, because this guy is fixed when we calculate M1, M2, M3, M4. Okay, and then we know this guy is 1.25. Okay, so we have the M, then we have the U. So U1 is now 10,001 plus the M. The M is 0.25 minus 0.4. When we add them, we get 10, 0.25, and 0.6. So far, so good, everybody. So let me write it down here. 10, 0.25, and 0.6. Okay? So this is the first steps. Yeah, Wunsch-Kruger method is more complicated than the Euler's method. And here we are only dealing with midpoints, so only K and M. But when we do with the Wunsch-Kruger fourth order methods, we have 4 k values, and each k values we have done the corresponding coordinates, so it would be more complicated in that case. Okay, so let's continue. Second step, when I equals 1, x1 equals, let's see, x1 is what? 1.5. So far so good. So k1 is the same formula, just increase the index, right? So h u2 of 1. H is 0.5, u2 of 1 is 0. So this is 0. Right? And then K2, this formula but increase the index. So h times minus 2 u of 1, sorry, u2 of 1 over x1. H is 0.5, u2 of 1. Oh, still 0. Nice. So this is also 0. And then K3 is same formula, h times u4 of 1. H is 0.5, u4 of 1 is 0.6. Well, the answer is 0.3 because it's half of 0.6 is 0.3. And then K4 is, we're gonna use this formula, increase the index. So 2 times u4 of 1, x1. So 0.5, u4 of 1 is 0.6, x1 is 1.5. Well, it's negative. 2 times 0.5 is 1. So it's the same as like 0.6 over 1.5. This is the same as 6 over 15, right? And 6 over 15, common factor is 3, so minus 2/5. Oh, this is the same as negative 0.4. So far, so good, everybody. So now we get the K's. How about the M? Well, M1 is then F1 of this, increase the index. So we're using this formula, just increase the index. So x1 plus 0.5h, and then this is u, now u of 1 plus 0.5k's. Okay, let's see. In this guy, x1 is 1.5, h is 0.5. So this now is becomes 1.75. Okay, and F1 is just U2, right? So it will be 0.5, H is 0.5 times U2 of 1 plus 0.5 K2. Well, the K2 means this guy is 0. Okay, so U2 of 1, oh, that's 0. And this is also 0. We still get 0. Nice. M2, okay, so is 0.5. Look at the previous formula. This guy. And then minus, so we get U2, oh, you know, U2 of 1 plus 0.5 K2, we already calculated, and that equals 0. So this is also 0. Then M3 is 0.5. So actually we just did one step, figure out the formulas. The second step, we just look at the previous steps and just increase the index and pick the correct number. Okay, update the value. So this is U4 of 1 plus 0.5 K4. U4 of 1 is 0.6. K4 is negative 0.4. Okay, Negative 0.4 times 0.5 is negative 0.2. 0.6 minus 0.2 is 0.4. 0.4 times 0.5 is 0.2. Is that okay, everybody? You can also put this in your calculator and calculate it. Okay, continue. M4 is then 0.5 minus 2 times U4 of 1 plus 0.5 K4 over the X now is 1.75. So that is 0.5. The negative we can put it in front. And then we have 2 times. Okay, what is this guy? Well, that guy is the same as this one. So 0.5 times minus 0.4 is minus 0.2. 0.6 minus 0.2 is 0.4. So this is 0.4 over 1.75. 2 times 0.5 is gone. So this is the same as saying 0.4 over 1.75 and negative. So 0.4 over 1.75. Okay, so the answer is, oh, you see what I type? I typed the dots, but sometimes the keyboard, maybe I didn't press the button strong enough. So this is our answer. Okay, so you have to be careful as well. Sometimes maybe you press the button and it does not show up there. So you have to look at the equation and double check whether you input the right thing. So 22857. So far, so good, everybody. Almost there. U2 is then U1 10 0.25.6 plus this m. This m is 0 0 and then 0.2 and then minus 0.22857. Okay, the first coordinate stay the same, 10 0. Third coordinate becomes 0.45. And then the last one, calculator, oops. We do we should do enter first, and then we do 0.6 minus our answer. 0.37143. Okay. So it's enough to keep 5 decimal places in your calculations. So far, so good, everybody. Okay, so this is the second order Runge-Kutta method. It's also called the midpoint method. Okay. Now let's talk about how to use MATLAB. Okay. Here we want to apply the Runge-Kutta midpoint method with n equals 10 to the system. Alright, with the initial conditions. So how we type the vector value function is the same as before. The syntax is RK2 sys. Okay, then you can see this is our initial condition for 3 2, and then you can see 10 points. Here are the 10 points, and we can also plot the graph. Okay. Let me type it here using Octave with you. Okay. Let's see. So we have F. F is, so this is 3 coordinates. Okay. So we have U2, U3. Oh, we have that. And then the last one change is X plus 2 times U1. We do U parentheses 1 minus 3 times U of parentheses 2 plus 4 times U parentheses 3. Okay, so that is F, and then we do the syntax. Is we're gonna do 10 steps. Initial conditions 4, 3, 2. The interval is still from 0 to 1. And this is RK2. 6. Let's see. Yep. Okay, so we're ready. Enter. Okay, so these are the points we get. So far, so good. We get 10 points. And we can also plot. So plot is right here. So far, so good, everybody. Okay. We can also check our work. Yeah, why don't we check our work? Yeah, we spend 20 minutes to work on this example. Let's check our work to see whether we're good. Okay, let's see. All right, so we have the function here, u2, and then we have minus 2 over x, and then times u of 2, and then we have u of 4, and then we have minus 2 divided by x times u of 4. Okay, and then we do 2 subintervals within initial conditions 10, 0, 0, 1. 10, 0, 0, 1. Interval is from 1 to 2. Okay. See? Do we have the same answer? Let's check our last point. Yeah, this is our last point. Do we have the same answer? Yes, we have the same answer. So far, so good? Yeah, so you can also use MATLAB to check your work. And actually, we can increase the steps, and then we can plot it. We'll get a nice smooth curve. Okay, so this is the coordinate functions. The u's in terms of x. All right, let's continue. Okay. Check example. Yeah, we just did, right? We checked our example and it matched. Okay, so that is the Wunsch-Kutta second order methods. Now, let's talk about the fourth order methods. We talked about this fourth order method in last chapter when we saw first order ordinary differential equations. We know there are 4 k values, right? Instead of 2 values for the midpoints, RK2 has 2 values, RK4 has 4 values. And then the yi's, we can also call them yi or ui as you want. I just put arrows on top of everything. The formula is very similar to what we had before. Okay, now we just view that each K1, K2, K3, K4, they are vectors. Okay, so let's continue. So for the index, because the K1, K2, K3, K4, I don't want to abuse of notation of the coordinates. I'm gonna use these notations. So if I do K1, 2, this is the K1. This is the second coordinate. Okay. Is that okay, everybody? Okay, so the first index is the number of K1, K2, K3, K4, 4 of them. Okay, the second index corresponds to the coordinates. Okay, so I'm gonna use this notation. Sorry, a lot of abuse of notations because we're working with vectors and there are more data involved. Okay, example 7. Approximate the solution of the following systems over 0, 1 using the fourth order Runge-Kutta methods with h equals 0.5. Okay, so this is interval from 0 to 1. This is 0.5. So this is x0, x1, and x2. So far, so good, everybody? And here we have u and v. Sometimes if you're so familiar with the u1, u2 notation, you can change this to u1 prime is u1 plus x times u2. u2 prime is 2u1 minus 3x u2. Okay, then you can get rid of the u and v. You can do whatever you want. Okay, but because if we have more coordinates, more dimensions, we just use the notation u1, u2, u3, un, right? Okay, so let's start. I equal to 0. Then, yeah, because if we use this notation, I can just use u of 0 to denote the first vector, u of 1 and u of 2. Okay. And u of 0 is then 2, 1. So far, so good? Okay. So, k1, 1. Okay, so k1 is the... This is the k1, okay? This is the first coordinate of the k1. So that is 0.5. So we call that formula k1 is 0.5, h is 0.5 times f. Okay, so let's look at the first coordinate. First coordinate is u1 of 0 plus x0, u2 of 0. So far, so good. And that's 0.5. u1 of 0 is 2. x0 is 0. Nice. 2 times 0.5 is 1. k1, 2. The second coordinate of k1 is 0.5 times f2. f2 is 2 times u1 of 0. And then minus 3x0. u2 of 0. Okay, that's 0.5 to u1 of 0 is 2. And x0 is 0, so it's gone. Oh, so this is just 2. So far, so good? Okay, so that's the two coordinates of k1. Now we do k2. k2 is then, what is the formula? h times f of xi plus 0.5h, then y plus 0.5 k1. Okay, so let me write it down here. So this is h oops. So h times f1 of x0 plus 0.5h. And then we do u of 0 plus 0.5 of k1. Okay, so x0 is 0. H is 0.5. So 0.5 times 0.5 is 0.25. So what is this? Well, h is 0.5, f1 is u, but here instead of u, we want to do u of 0. So that is u1 of 0 plus x. The x0 is not this x, replace x by 0.25. So this is 0.25 times sorry, I'm missing the sometimes we have to be very careful because this is the u1 is u1 of 0 plus 0.5 of K11, okay, plus x. X is 0.25 times U2. U2 is U2 of 0 plus 0.5 K12. Okay, let's figure out what this is. So this is 0.5. U1 of 0 is 2 plus 0.5 times K11 is 1 plus 0.25 times U2 of 0, which is 1, plus 0.5 K12 is 2. Okay, that is 0.5, 2 plus 0.5, 2.5, plus 0.25. 2 times 0.5 is 1, 1 plus 1, 2. Oh, 2 times 0.25 is 0.5, plus 2.5 is 3. So this is the same as 0.5 times 3. So this is 1.5. Is that okay, everybody? Yeah, we're working like I would say this could be the most complicated problem in our course, because a lot of vectors, coordinates. Okay, so and we have to calm down, be patient, and work slowly, and make sure we get the correct number. Okay, K22 is then H times, well, this is F2. F2 is okay, let me write it down. So F2 of x0 plus 0.5 h, this is still 0.25, but this is u0 plus 0.5 of k1. Okay, so 0.5, and then we have 2u. When you see u, that's the u1 of 0. Sorry, let me write it better. u1 of 0 plus 0.5 k1 minus 3x, x is 0.25. The v is like u2. u2 is u2 of 0 plus 0.5 k12. Okay, let's see what is that. What is this number? Well, this number is the same as this number. That is 2 plus 0.5. This is 2.5. Right? And don't forget the 2 in front of it. So 2 times 2.5 minus 3 times 0.25. Well, what is this number? Well, this number is the same as this guy. And that equals, this is 2. That's the same as 2. Okay, 2 times 2.5 is 5. 2 times 0.25 is 0.5. 3 times 0.5 is 1.5. Oh, 5 minus 1.5 is 3.5. 3.5 times 0.5 is 1.75. Great. If you want to use a calculator for that, feel free to use a calculator. Okay? Yes. Sometimes I just feel like the number, if it's not so complicated, and maybe calculating is faster than typing it in the calculator. Okay. K, and then we see this is only K2. We still have K3. Well, K3, what is the formula? It's similar with the K2, but just instead of K1, now we have K2. So it's similar as before. Let me use a different color. Okay, so K31 is H times F1. Ooh, this is still the same. This is still x0 plus 0.5h. So we know this is 0.25. And then we have u of 0 plus 0.5. Now this is k2. Okay, everybody? So similar to what we had before, like here, similar to this guy, but we have u1 of 0 plus 0.5. Instead of k11, we have k21. Okay, and then we have the 0.25, u2 0 plus 0.5. Instead of k12, we have k22. Okay, let's figure out what these numbers are. So, this guy, 2 plus 0.5 times k21 is 1.5. 0.25 u2 0 is, let's see, u2 0 is 1, right? And then we have 0.5 of k22 is 1.75. Okay, so what is this number? Okay, this guy, I need the calculator. So 0.5 times 2 plus 0.5 times 1.5. Actually, that's 0.75. Plus 0.25. And then times 1 plus 0.5 times 1.75. Okay, so the answer is 1.609375. 1.609375. Okay, so that's K31. We have K32. Can you imagine? This is only the first step. But today we only do the first step, okay? I will leave the second step as an exercise for you. Okay, so this is still 0.25. And here u of 0 plus 0.5 K2. Well, see, it's very similar. Just replace, oh, I think I have had a miss. I missed something. This guy should be K11. Okay, so now just change the K1, replace it by K2. So this is 2 of u1 0 plus 0.5 K21. So K21 minus 3 times 0.25. And then u2 of 0 plus 0.5 times K22. Okay, and what is that number? It's very similar to what we had before, but we just changed something. So 2 times, this is 2 plus 0.5 times 1.5, minus 3 times 0.25, and this is 1 plus 0.5 times 1.75. See, I just copied down here, but changed some number. Okay, so far so good. Let's see. Plug this in our calculator. Calculator, where are you? I'm gonna copy the last line and just change some number. Here, input parentheses, and I need 3 times this number. Oops, sorry, 2 times that number. And then minus 3 times that number and that number. Okay, good. So the answer is 2.046875. 2.046875. And this is just K3. We still have K4, but almost there. Okay, you might ask, will I ask you these questions in the exam? The answer is no. we don't have time for like this kind of problem. But this is important. We need to know how it works. So I still need to teach it, and you still need to learn it. Even though we don't have time to test on the exam, it doesn't mean that we don't need to know it. So we still need to learn it. We're here to learn. We're not here for the grades, right? Okay, you might think we're here for the grade as well, but yeah, sorry, I talk too much. Okay, h4 is h times f of xi plus h, yi plus k3. Okay, so this is h f1 x0 plus h, and then u of 0 plus k3. H is 0.5, and then f1. Okay, what is this number? So x0 is, let's see, 0. Okay, so h is 0.5, so this guy is just 0.5. And then this one is u1 of 0 plus k31. And then the x is 0.5. And then u2 of 0 plus so I'm looking at this guy, okay? So it's good to look at the last step and think about what's gonna change, what are similar, what are the same. So then we just change, so we don't have this guy, okay? And we replace k21 by k31, and this the x instead of 0.25, now we have 0.5, and here we don't have the 0.5, so just k32. Okay, u10 is 2, k31 is 1.609375. And u20 is 1, k32 2.046875. Okay, let's see what this is. Calculator. So we have, let me copy this down here. Let's see, 1.6. So we place this number by that number, and this is 0.5. Okay, so you just compare which one is the same, then we don't change it. Which one is different, we change it. Then we don't need to retype everything again. Okay, so 2.6640.625. 2.5664, 0, and then what? 625. K42 is h times f2. This is still 0.5. This is still u plus k3. Okay, what's gonna change? It's like you combine this formula and this formula. So we have 0.5, and then 2 times u1 of 0 plus no 0.5, so k31, minus 3 times 0.25, and then u2 of 0 plus no 0.5, so just k32. Okay, what are these numbers? So this is 2 plus 1.609375 minus 3 times, oh sorry, this is not 0.25, this is just 0.5. Okay, and then 1 plus 2.046875. So that's why it's good to write out everything, because if we make a mistake, I still give you a lot of points, partial credits, because you show me your steps. I know you understand the process, how to solve these kind of problems, so you get most of the points. Okay, so next we gonna take this guy, put it down here, And then let's insert a parentheses because I want to multiply by 2. And here we subtract 3 times that number. Okay, are we good? Yep. 1.3. Let's see. 1.32421. And then 875. Whew, so that's K1, K2, K3, K4. Last. What is that? Okay, that is the Y or the U1. U1 is the vector. So is the U of 0 plus 1 over 6 K1 plus 1 over 3 K2 plus 1 over 3 K3 plus 1 over 6 K4. Okay, so that's the first steps. So U0 is 2, 1. Okay. So U of 1 is U0 is 2, 1 plus 1 over 6 K1. Wow. What's K1 here? 1, 2, and then 1.5, 1.75. Okay, 1, 2, 1.5, 1.75. And then K3 is still 1/3. What's K3? 1.6099375, 2.046875, and then 1 over 6. 2.566400625, 1.32421875. Phew. Okay, now let's do that calculation. Okay, let's look at the first coordinates. So that is 2 plus 1 over 6 times 1 is 1 over 6 plus 1.5 divided by 3 plus 1.6099375 divided by 3 plus, oops, you see what happened? I have to go back up here. Otherwise, the plus will be downstairs. And this is 2.0. Let me copy down here. Then I don't need to type the whole thing again. Over 6. Okay, so enter. This is our first step. 3.63086. Okay, let's keep 5 decimal places. Okay, next. Oops, sorry. I'm gonna copy it. Then we place what we're gonna change. This is 1. That is 2. This guy is 1.75. This guy is 2.04685. Next one is 1.32. I got this number, copy and paste here. See? Yeah, so compare and change the numbers. We can save some work. So 2.81966. So far, so good. This is only the first steps. Second steps left as exercise. But now you can see it's quite a long process. Because RK4, we have the 4 K values, K1, K2, K3, K4, and each of them has 2 coordinates. So there are 8 equations, right? And the U1 is a linear combination of the U0 and the KI's. So another 2 equations. So 10 equations in one step. Okay? Alright, so luckily I won't ask you this problem in the exam. Okay, so this is RK2, this is RK4, right? So we can use RK4 to check our work. Okay, so continue with the same example. We can compare RK2. We have RK2 system. RK4, we just type RK4, and let's compare. Okay, so this is an example. When we type RK4, we also get the xi's, and we have 10 vectors for the u's. Okay, so let's see. Alright, so we do RK4. Let's do 10 steps. And so this is RK4. Okay, so these are the 10 vectors we get for U. So far, so good? Okay. And let's look at the last number. Here, let's see here. The last number. Oh, let's see. Do we have the same problem? Let's see. Okay. Because our F might change. Let's see. What's the F? Oh, see, we changed the F. So let's find the old F. This is the older F. And then we can do RK4. Okay, so let's see. Oh, okay. So we also need to change the initial conditions. Here we have 4 coordinates. What are the initial conditions? They are, let me find the one. Yes, this is the initial condition. Okay, so RK4. So this is the values we get. So far, so good, everybody. And let's look at the last number. We get 70.6233. Let's compare. Okay, let's compare RK4 50 and RK2 50. Okay, so RK4 50. Look at the last number. 76409. So keep that in mind. If we do RK2, if just get 50, we just get 7 point something, right? But if we increase, we add RK2, let's do 300. See, we get 6361. Let me. What was the RK4 50? I don't remember now. Let's do it again. So RK4 50. Okay, 6409. 6409. And RK2, let's do 3500. Oh, that's a lot. Yes. See? We get 6409. So it means 50 subintervals in the RK4 methods, we get the same answer as 3,500 subintervals of the RK2. Then we can see RK4 is more accurate compared with the RK2. And it makes sense because RK4 we have 4 K values, and RK2 there's only 2 K values. Okay, so RK4 should converge, should be more accurate than the RK2. Let's see whether it really needs 3,500 to get to that number, 6409. Let's do 500. Would that work? No, you see, 6409 is not that one. Let's do 1500. 6407. You see? You actually really need to get, let's do 2. 6908. See, it actually needs around 3,500 subintervals to get the same accuracy as the 50 subintervals in the RK4 method. Okay, so this is today we talk about the Runge-Kutta methods, and we have the midpoints and the fourth order Runge-Kutta methods. Okay. All right, so please work on your homework and then do some exercise. Even though we don't test these problems in the exams, but I hope you still know how to apply it. Okay, have a nice day. Bye.